So we've learned that if we have the appropriate components and we hook them up in a circuit so that the current flows from the positive side of the battery through the components back to the negative, we can actually do things like light up a light. We can make all kinds of different electronic circuits. The question is, how do we communicate that design to other people? What if we wanted someone else to build the circuits for us? Or what if we just wanted to capture the idea so we'd remember it for later? The answer is that we use circuit diagrams, also known as schematics. Now, the key to circuit diagrams is that each component that we're likely to use has its own symbol. So let's get started and take a look at what are the common symbols there are. There's many of these, but these are going to be some of the most common that you will use. The first thing is a battery. Okay, so usually it looks like something like this. There are variations. There's other types of power sources, but this is a nice battery. And because batteries come in different voltages, these are usually labeled in our diagram with a voltage. The next is the LED. This is the little device that lights up when current flows through it at the appropriate amount. And it looks something like this. Pretty elaborate. Now you might notice that I've drawn this one left to right, this one top to bottom. The orientation of these doesn't matter. You'll see that when we make our circuit diagram, we'll just make the orientation so it fits well into the diagram. The next is the resistor, and in the United States we use this symbol. They actually use something different in Europe. So it's a jaggedy line, and because resistors come in different values, we're going to usually label this with the resistance that it has. A button. So a button actually is a way to make a break, in the circuit, and then the circuit is only complete when the button is pressed. Its symbol looks like this. So there is a sort of a drawing of a broken circuit, and then it has this top part. So you can kind of imagine this being the button part, and when you press it down, it actually completes the circuit. A switch is similar in its behavior, possibly, to a button, but it stays in the position that you put it in. So the switch, there's a couple different kinds. First, if it's just a switch that breaks or completes a circuit, it would look like this, but you might notice that this switch has actually 3 legs. The way this works is the current flows into the middle leg, and it can be routed either to the left leg or to the right leg. So if, for example, the switch is over here to the right, it means the current flows into the middle and then out the right. If you turn the switch the other way, then it'll flow in the middle and out the left. Now notice that this looks like it is in one particular orientation. This just means it's a switch. It does not mean that it's in any particular orientation. Okay, we're going to be using motors at some point. So what does a motor look like? Usually it's just something, a circle with an M, and then it has these little connectors, these terminals that look like that. And there's the leads going into it. Buzzer, or actually this is also the same for a speaker. It looks a little bit like a drawing of a small speaker. Okay, so here are very common circuit symbols. Now let's go ahead and take some of these and combine them into an actual circuit diagram. Okay, so I'm going to do a battery, a resistor, and an LED. So first of all, which is the circuit symbol for a battery? Yes, that is correct. Very good. So I'm going to go ahead and draw that. And I'm going to put my 9-volt beside it. Now, the next thing I want to do is I want this to go to resistor. And I'm going to draw a connecting line like this. Okay, so you might be wondering, what is this line? And actually, we're not really specifying how this connection is made. We're just saying that somehow the output, the positive side of this battery, is going to one leg of the resistor. All right, so I'm going to go ahead and put 330 ohms on here for example, and then I'm going to draw it like this. Here is my LED. Notice it's pointing down, doesn't matter the orientation in the diagram. And so there is our circuit symbol. You can see that it is a complete circuit because the line goes through the components and returns back to the negative side. Now, a couple things you might be wondering. First of all, does the order that the components appear matter? And the answer is no. The current is actually constant throughout the entire thing, and it is the value of the current is determined by the voltage and the resistor and the way the LED behaves, but the order does not matter. The other thing that is an important question is, does the orientation left and right of these matter? Okay, so resistors, you can put it this way, or you can actually turn it 180 degrees and put it that way, and it will behave exactly the same. And the circuit symbol actually kind of indicates that. If you think about it, it looks the same going left to right as right to left. The LED, on the other hand, is different. There is an orientation, so if the current's going from, in this case, top to bottom, it is different than bottom to top. And that is because for an LED to light up, the longer leg must be near on the positive side of the circuit, and the shorter leg on the negative side. Great. So we've made our first circuit diagram, and I would like you to get in the habit of making these, being able to draw them, as well as being able to read them and construct circuits from them. So what I'd like you to do now is go ahead and make a very similar circuit, but this time, go ahead and add in a button. You should pause the video and give this a shot, and then when you're done, come back and we'll do this together. All right, hopefully you've had a chance to draw that circuit. Now I'm going to draw it myself. I have the 9-volt battery once again, so I'm going to draw that. I'll do 9 volts. And now I am choosing to put my button in here. You could actually put it anywhere in the circuit, but I'm just going to put it right here like this. And then I have my resistor. Label your resistor with the resistance. And then I have my LED again. And I must complete the circuit for the current to flow, and there it is. So this is a completed circuit. This time, the way this circuit will behave is nothing will happen until you press that battery, then the light will light up. Another thing to mention, now that we have circuit diagrams, it makes it easier to talk about how circuits work. This is when there are components one after the other on a single pathway. We call that series. These components are in series. So series is one after the other. But sometimes you can actually have a situation where, let's say the current's flowing along here, and it actually branches into two different paths. Let's say that we had a second LED over here. So what happens is some of the current flows this way and some of the current flows this way. And then when they come back to this junction down here, they recombine into the single current, which then flows back to the negative. When you have this type of situation, we actually call that parallel. We would say that those two LEDs are in parallel.